awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih.
Assalamualaikum and hi everyone. So welcome back. So now we want to discuss 5 examples that related to subtopic 2.1 and 2.2. Jadi untuk soalan 2.1 saya ada video yang lama yang awak boleh tengok dekat sini. Okey, dan untuk video kali ini kita lebihkan soalan daripada subtopic 2.2 berkenaan dengan charging and discharging. Okey, so jom kita mulakan dengan soalan yang pertama. Alright, so example number 1. So here we have a circuit and we have 4 capacitors. So let's label all the capacitors first. So let's say this is C1 and this is C2. Alright, and this is C3 and the last one is C4. Okay, so first, question A, find the equivalent capacitance of the arrangement of capacitors shown below. Okay, so we want to find the equivalent capacitance or total capacitance of this circuit. Alright, so now let's start with the first one. Okay, so A, so saya akan mulakan dengan C1 and C2 because we want to simplify this circuit first. Okay, so kalau kita nak tahu mana series, mana parallel, sorry. Okay, so tengok pada inilah current flow from positive terminal and then we have junction here. So what happens? So the current will split into 2 parts. Okay, so kat sini pun ada satu lagi junction. Okay, so kita tukar colour lah. So bila dia split, saya ambil colour lain lah. Ini colour biru ini. Okay, so yang ni pula kita letak lagi satu colour. Let's say orange colour. Okay, macam tu. Okay, kenapa saya letak colour yang berbeza? Okay, untuk tunjuk dekat awak lah that the flow of current that pass through C1 and C2 merupakan current yang berbeza. Okay, kita ada colour hijau dekat sini, daripada sini tadi. Okay, and then at this junction, it will split into 2 paths. Alright, so this is the dark blue. Alright, and this is the light blue. And until this junction, so the current split into 2 paths again. So we have orange color and this is the pink color. Alright, pink or purple. Okay, from this flow of current, we can say that C1 and C2 are parallel. Okay, sebab current yang lalu dekat C1 tak sama dengan current yang lalu dekat C2. Alright, so I will write that C1 and C2. So saya akan solvekan untuk C1 and C2 dulu. Okay, so kita akan dapat bila kita combinekan C1 and C2, so kita akan dapat C12 is equal to, so formula to calculate the total capacitor in parallel, so C1 plus C2. Okay, so this one is very simple. So we have 1 micro plus 5 micro, therefore C12 is given 6 microfarad. Okay, so kita baru ada C12. Okay, belum jawapan lagi. Alright, and then bila kita dah settlekan C12, okay, so circuit kita akan jadi macam mana? So dia akan jadi macam inilah. So kita ada C3 here and here is C12. Alright, and then we have C4 here. Okay, and this is the battery. Okay, okay. So now look at here, we can try to solve for C3 and C12. Okay, since the current that flow from here, from this junction, current yang lalu dekat C3 sama juga dengan current yang lalu dekat kumpulan C12. Therefore, they are in series. Okay, so this is series. So we can try to solve. Okay, series. Kalau ini tadi dia adalah parallel. Okay. Alright, so for series, so we want to calculate C3 and C13. So C3 and C12, sorry. So they are in series. Okay. So 1 over C123, so formula for series capacitors. Alright, so kita nak tambahkan 1 over C3 plus 1 over C12. Okay, so tengok betul-betul dekat sini adalah 1 over C123. Kita nak cari C123. Alright, so C123 is equal to 1 over, okay, 1 over C3 which is 4 micro plus 1 over C12 tadi kita dah kira 6 micro. Alright, so kita dapatlah C123 is equal to 2.4 microfarad. Okay, so ini baru dapat C123. And then let's move to another part. Okay, so bila kita combinekan pula, this is C123 yang kita dah kira tadi, and C123 and C4 are in parallel. Okay, so finally we can try to solve for C123 and C4, and they are parallel. This is very important. Alright, so kita boleh letaklah C equivalent ataupun C total. Okay, ataupun kita nak tulis C1, 2, 3, 4 pun boleh jugalah. Okay, kita adalah tambah C1, 2, 3 plus C4. Okay, so equivalent capacitance therefore equal to 2.4 micro plus 6 micro. Sorry, C4 dia bagi 3 kan, 3 micro. And the answer is equal to 5.4. Okay, boleh so 5.4. Okay, so this is the final answer. Okay, 5.4 microfarad. Okay, and then B. Okay, we want to calculate the charge on the 4 microfarad capacitor. So 4 microfarad is referring to C3. Okay, so jadi untuk soalan B, okay, untuk soalan B, kita nak cari charge on capacitor 3. Okay, kita nak cari ini, charge on capacitor 3. Okay, jadi kita nampaklah final ni, kita nampak dekat sini, this is parallel. Alright, and as we know, okay, charge for capacitor 3, since 1, 2, 3 is C1, 2, 3 is in series here. Okay, mana tadi? This one. Okay, C1, 2 and C3 are in series. Okay, so kita boleh kira lah Q1, 2, 3. Okay, so kena faham kita nak cari, okay, awak nak cari apa? Awak nak cari charge dekat capacitor 3. Okay, so kita nampak capacitor 3 duduk dekat sini. Okay, and it is series with C12. Alright, therefore when we calculate the total charge of 1, 2, 3, it is actually equal to Q12 and also equal to Q3. Sebab apa? Sebab mereka adalah in series. C12 and C3 are in series. Okay, so kita boleh dapatlah straightly Q3 dekat sini by calculating the value of Q123 is equal to C123 plus times V, right? Times V. Okay, so now V123, okay, in order to calculate Q123, kita dah ada nilai C123, tapi kita tak ada V123. But we can straightly find V123. Okay, you tengok dekat sini. This is, the last one is the parallel circuit. So, since here is 10 volt. Okay, awak kena hafal lah. So, sini mesti sama dengan sini. Voltage across V123 equal to V4 equal to V total. Okay. Iaitu 10 volt. So, kita terus dapat. Dan kita boleh terus kira lah. C123 is equal to 2.4 micro. V123 is 10 volt. Okay, ini dia tadi. Boleh So, dapatlah jawapan Q123 is equal to 24 microcoulomb. Therefore, since Q123 is equal to Q3, so kita dapat jawapan untuk Q3. So kena faham kenapa Q123 sama dengan Q3? Sebab C123 ni tadi mereka series. Okay, so bila kita kira Q123, so siapa yang series ni? C3 dengan C123. That's why Q123 sama dengan Q12 sama dengan Q3. Okay, so final answer is equal to 24 microcoulomb. Okay, so this is the answer. And the last one. Okay. So now I want to calculate what is the energy stored in 5 microcoulomb capacitor. Okay, so by referring to this circuit, 5 microfarad is C2. Okay, so C2, so kita nak kira U2 equal to half, okay, C2 V2 squared. So boleh gunalah formula yang ini kalau kita nak guna. Okay, ataupun kita nak guna formula yang ini pun boleh, half Q squared over V ataupun half QV pun boleh juga. Okay, so kita perlu ada charge Q2 dan juga V2. Okay, so saya tak guna yang inilah. So saya akan guna yang ini. Cumanya saya perlu cari ini, nilai V2. Okay, voltage across this one, C2. Okay, kita boleh cari V12. Okay, so Q12 saya dah ada. Okay, di mana Q12 is equal to 24, right? Okay, 24 microcoulomb. Okay, kenapa saya tahu Q12 24 microcoulomb? Okay, sebab ini tadi. Q12 sama dengan Q123, which is 24. Okay, so kita boleh carilah. Q12, so saya dah boleh cari V12 is equal to Q12 over C12. Okay, so Q12 24 micro, C12 kita dah kira tadi 6 micro. Okay, so kita akan dapat V12 is equal to 4 volt. Alright, and then kita tanya diri kita, gabungan capacitor 1 dengan capacitor 2 tadi, ini kita dah nampak tadi C1 V12. So ini mereka adalah gabungan C1 dengan C2, mereka adalah parallel. Okay, so bila mereka adalah parallel, means that V12 sama dengan V1 sama dengan V2. Okay, so ini yang kita nak kena faham dan ingat. Okay, sebab tu saya suka tulis ini V12. So saya tahu dia refer kepada parallel combination antara V1 dan juga V2. Alright, so sekarang saya dah ada V2, okay, iaitu 4 volt. Therefore, we can find U2 energy stored in 5 microfarad capacitor, which is half. So C2 tadi 5 micro and V2 is 4. Okay, and finally, berapa jawapan kita akan dapat? 3.2 times 10 power of negative 5 joule. Okay, jadi inilah jawapannya. Alright, so finish example number 1. Alright, example number 2. So let's read the question. Refer to figure 1 below. So this is the figure. If the switch S, alright, is connected to A, calculate the time constant of the circuit. Alright, so look at here, this is the switch. So when the switch S is connected to point A here, means that we have this circuit. Alright, so we have a battery, and this is the resistance, and this is the capacitance. Alright, so kita ada capacitor of capacitance 15 microfarad. Apa yang berlaku dekat sini? Ini tak adalah. Okay, sebab kita hanya sambungkan switch S pada point A sahaja. Okay, so dia hanya ada ini sahaja. Okay, circuit yang saya highlightkan ini. Okay, ini sahaja. Okay, so now untuk A kita boleh kira lah. Okay, in order to calculate the time constant, we can straightly find by using this equation. Tau is equal to RC. Very simple. Okay, so R dah ada, we can just substitute 200 and this is C1, where C1 is 15 micro. Okay, so C1 is 15 microfarad. Okay, therefore kita kira lah. So kita akan dapat 3 times 10 power of negative 3 second, or we can just leave the answer in millisecond. Okay, so this is the answer. Alright, and then B, calculate the maximum charge on C1. So we can find what is the maximum charge that can be stored by capacitor 1. So we can use this equation, C1 times V, and we have C1 15 micro, where V is equal to 6. So 15 times 6. Okay, so kita akan dapat berapa tu? Okay, 90 So 90 micro coulomb. Ataupun kita nak tulis macam ini pun boleh lah. 9 times 10 power of negative 5 coulomb. Okay, so this is the answer. Okay, and then question C. After capacitor 1 is fully charged, the switch here is then connected to point B. Alright, so means that, okay, we remove the battery. So we just have this circuit C1 and this is another capacitor here, C2. And as we know that C1 here is fully charged. Okay, where Q1 is equal to, kita dah kira dah tadi, 90 microcoulomb. Okay, so sekarang soalan minta kita kira, okay, the charge on capacitor 2, C2 after reaching equilibrium state. Okay, so for this question, you can see here that C1 is the only capacitor that is fully charged. So when C2, okay, C2 yang kosong tadi connected to C1, some of the charge from C1 can be transferred to C2. So soalan minta kita kira lah nilai Q2. Okay, so kita tahu the total charge, okay, initially pada mulanya the total charge in this circuit adalah 90 microcoulomb. So dia ada Q1, okay, tambah Q2. Dia akan bagi sikit dekat Q1 ada sikit, dekat Q2 pun ada sikit. Okay, jadi kalau kita nampak ni, okay, bila C2 connected dengan C1, okay, ini kita nampak this is the characteristic of parallel. Kan kalau parallel combination, the charge Q1 tambah dengan Q2 akan jadi total charge. Okay, so the total charge yang kita ada pada mulanya hanyalah 90 microcoulomb. Boleh Okay, so sekarang bila parallel, okay, kita kira dulu C total. Okay, so let's calculate first what is C total. So kita ada C1 plus C2. Okay, so where C1 is 15 microfarad and C2 is 5, so C total is 20 microfarad. Okay, therefore we can find V total, okay, which is equal to, okay, Q total over C total. So Q total tadi 90 micro, C total is 20 micro. Okay, so kita akan dapat 4.5 volt. Okay, since C1 and C2 is parallel, therefore V total is equal to V1 is equal to V2 and it is equal to 4.5 volt. Okay, so kena ingatlah yang ini. Okay, bila parallel ni, okay, so can we find what is the charge in C2? Okay, so kita boleh kira lah Q2 equal to C2 V2, where C2 is equal to 5 micro and V2 is 4.5. Okay, so kita dapatlah 22.5. microcoulomb. Okay, so this is the answer for question C. Alright, so finish example number 2. Let's proceed to the next example. Okay, question number 3. So a fully charged capacitor has 12 microfarad and 6 millicoulomb charge. So the capacitor has been discharged through 100 ohm resistors. So determine potential difference across the capacitor. Okay, so when the capacitor is fully charged, okay, for A, when the capacitor is fully charged, okay, means that voltage across the capacitor is equal to voltage that supplied to the circuit lah. Okay, equal to supplied voltage V0. Alright, so sekarang soalan minta kita kira potential difference across the capacitor. Okay, so kita nak kira V lah, V0 ataupun VC. Okay, so sebab kita nak kira VC ni, tapi VC kan sama dengan V0, so kita boleh masukkan formula V0 is equal to dia kata fully charged capacitor yang ini tadi, dia ada ini. Sorry, this one. Okay, charge dia yang ini. So V0 is equal to Q0 over C. Okay, so bila masa dia fully charged tadi, dia ada 6 millicoulomb. Okay, over capacitor is given 12 microfarad. So V0 dia adalah 500 volt. Okay, so daripada situ kita dah tahulah potential difference across the capacitor masa dia fully charged tadi. VC dia berapa? Okay, so VC dia is equal to 500 volt. Jadi kita kena faham. So bila capacitor is fully charged, means that masa dia fully charged tadi, the potential difference across the capacitor sama dengan potential difference bateri. Contohnya kan, kita ada bateri ataupun supplied voltage dia. So V0. Okay, so kita kena faham dekat situ. Kalau soalan ni tiba-tiba tukar, determine the potential difference of the battery. Kan, yang kita gunakan. So jawapan dia inilah. So kita kena tahu masa capacitor fully charged means that potential difference across the capacitor is equal to V0. Okay, where V0 is the supplied voltage. Okay, and then B. Okay, the time constant for charging circuit. Okay, so the time constant we can just use for RC. Okay, we can use this equation. Okay, R kita dah tahu dah, dia dah bagi 100 and C is 12 micro. So boleh dapat lah. Okay, 1.2 millisecond ataupun 1.2 exponent negative 3 second. Okay, C. Okay, calculate the time taken if just 20% charge left in this capacitor. Okay, maknanya hanya tinggal 20% charge saja from the maximum charge tadi, hanya tinggal 20% in the capacitor. So berapa masa yang diambil untuk charge yang maksimum tadi, yang 6 millicoulomb ni tadi, untuk tinggal 20%. Okay, so 20% actually is equal to 0.2 Q0. Okay, so by using equation, okay, untuk equation discharging, okay, sebab kita tahu charge dia semakin berkurang kan, so discharging process, so we can just use this equation. Okay, formula ni kena ingat lah. Kalau diberi boleh gunakan saja terus. So Q final dia dah bagi tahu dah condition dia 20% of maximum charge, which is 0.2 Q0 equal to Q0 E negative T over R kita nak cari. Sorry, T kita nak cari. Ini kita nak carilah. So R dia dah bagi 100. Okay, and then C is 12 micro. Okay, so Q0 kita boleh cancel out and we can take ln for both side. Okay, so E, so negative T over 1.2 times 10 power of negative 3 So this is actually the time constant tadi lah, RC. Okay, so this one would be cancel. Okay, mathematics ni jadi 1. Yang ni semua bawa pergi ke depan. Okay, so ln 2 you akan dapat negative 1.609 and negative t over 1.2 exponent negative 3. So negative ni can cancel out. Therefore, t is equal to 1.93 times 10 power of negative 3 second. Okay, so this is the answer for question C. And then D, okay, sketch I against T graph to show discharging process. So this is I and this is T. Alright, so kita boleh kira lah. This is actually I0. Kalau nak kira nilai I0 ni, kalau kita nak kira nilai I0 ni boleh je. I0 equal to V0 over R. Okay, V is equal to IR. So V0 tadi adalah 500, R dia adalah 100. So I0, okay, 5 ampere. So kalau nak labelkan I0 ni, tulislah I0 equal to 5 okay, negative 5 to show the direction of flow of current which is in opposite direction. Okay, so kita sketchkan macam itu saja. Okay, so finish example number 3. Alright, example number 4. Okay, we start with 4A. So we have 2 microfarad capacitor here. Is charged to 10 volt and then discharged through a 1 mega ohm resistor. What is the time taken for the potential difference across the capacitor to drop to 5 volt? Okay, jadi perkataan perkataan potential difference across capacitor, okay, referring to VC drop. So bila ada perkataan drop ni, maknanya dia adalah discharging process. Okay, so maknanya VC, okay, decreasing ataupun drop. Okay, so we can start with question A. Okay, so okay, kita tahulah V final dia akan drop sehingga 5 volt and we can use equation voltage for discharging V0 E negative T over RC. Okay, jadi R kita dah ada, C pun kita dah ada, and V0 pun kita dah ada, actually this one. Okay, 10 volt. Okay, so kita boleh carilah V tadi 5. So dia nak apa? Time taken kan? Dia nak T lah. So this one 10. Kalau dia dah ada, kita boleh straightly masukkan sajalah. R is 1 mega. C adalah 2 micro. Okay. So kita kira lah this one sama je macam tadi. Okay. And 5 bagi 10, 0.5. So we can take ln. So ln E negative T over. Okay, this one tadi. Nak selesaikan dulu pun boleh. Okay, so this one should be 1. Okay, yang ni semua bawa turun ke sini. Okay, so ln 0.5 negatif 0.6931 negatif T over 2. Alright. So cancel negatif. T you akan dapat 1.39 second. Jadi dia mengambil masa 1.39 saat untuk voltage across capacitor drop from 10 volt to 5 volt. Okay. Finish A and B. A 2 microfarad capacitor, okay, which is initially uncharged. Okay, kita ada capacitor. Okay, uncharged capacitor is connected in series with 25 kilo ohm resistor. A switch is given 10 volt battery, a switch and a 10 volt battery. When the switch is closed, calculate the initial current. Okay, so initial current, okay. Okay, actually the current that passed through resistor in the circuit V is equal to IR. And V here should be V0, V daripada bateri. Okay, kita nak cari I0 is equal to V0 over R. So V is given 100 volt. R is 25 kilo. Okay. So, dapatlah nanti I. I dia adalah 4 times 10 power of negative 3 ampere. Okay, ingat bila soalan minta kita kira the maximum current, so dia mesti ini, formula ini, V0 daripada bateri. Okay, bahagikan dengan resistance in the circuit. Okay, so ini 1. Okay, second. The maximum charge Q0 equal to C0 V0. Okay, so kapasitor kita pakai 2 micro and V tadi adalah bateri 100. Okay, so maximum charge stored in the capacitor should be 200 microcoulomb. Okay, so this is the answer. And then next, number 3. The charge after 0.01 second, okay, given that T is 0.01 second. Okay, jadi soalan minta kita kira charge in the capacitor, okay, untuk masa 0.01 second. Okay, so this is charging process. Kenapa saya kata charging process? Sebabnya capacitor ni tadi initially uncharged. Okay, so maknanya dia perlu charge lah selama 0.01 second ni. Kita nak tahu berapa charge yang dah terkumpul. Okay, so formula apa kita nak pakai? Mestilah kita guna formula charging. Okay, where Q is equal to Q0 bracket 1 minus E negative T over RC. Okay, so kita boleh masukkanlah dekat situ, where Q is equal to Q0 tadi kita dah kira 200 micro, okay, and 1 minus E negative T kita 0.01 second soalan minta, and R is given 25 kilo, okay, kilo, and C adalah 2 micro farad. Okay, awak selesaikanlah ni selesaikan. Jawapannya adalah 3.63 times 10 power of negative 5 coulomb. Okay, jadinya untuk kosong, okay, daripada kosong, charge dia kosong, so dalam masa 0.01 second, charge yang terkumpul dalam kapasitor itu adalah 3.63 times 10 power of negative 5 coulomb. Okay, boleh? Okay. Alright, now the last question. Okay, so here we have the RC circuit. The battery has fully charged the capacitor. So this is the battery, okay, and the battery, okay, has fully charged this capacitor. So given that at T is equal to 0 second, okay, the switch S is thrown from position A to B. Okay, so this is discharging process. Maknanya switch ni tadi, okay, dari mula-mula dekat A, lepas tu kita akan pasang dekat B. Okay, bila kita pasang dekat B, maknanya ini dia akan cancel lah. Okay, jadi circuit dia akan jadi macam inilah. Itu clue di mana nak menunjukkan this is discharging process. Okay, we remove the battery. Okay. So, when the capacitor has fully charged tadi, okay, so we know that we can calculate Q0, okay. The current I is observed to decrease, yes, because this is discharging process to 0.5 of its initial value in 40 microsecond. Okay, so in T, in 40 microsecond, okay, I is equal to 0.5 of its initial current. Boleh? Okay, so this is discharging process. Okay, jadi soalan A minta kita kira value of R. Okay, so we can calculate value of R sebab kita dah ada maklumat. Okay, so kita boleh gunalah formula current. Jadi kita dah ada time, kita dah ada C, saya dah boleh cari R lah. Where current at 40 microsecond, current tadi adalah 0.5 I0. Okay, so this one 40 microsecond. So R kita nak cari, sekejap ni saya besarkan sikit. Okay, negative 40 microsecond bahagikan dengan R kita nak cari. C tadi berapa? 1.02 micro. Okay, ini yang kita nak carilah R. Micro ni boleh cancel kalau kita nak cancel. Okay, so this one also we can cancel I0 and we can take ln for both sides. So negative, this one should be 40 divide 1.02, 39.216 R. Okay, so we can try to solve. Okay, cancel the negative. Therefore, R is equal to 56.6 ohm. Okay, so this is the answer for A. And then B, we want to calculate the time constant. Okay, I will try to calculate here. Okay, time constant is equal to RC, where R is equal to 56.6. Okay, we already calculate. So C is 1.02 exponent negative 6. And time constant is 5.8 times 10 power of negative 5 second. Okay. So ini jawapannya. And then C, the value of the charge Q on the capacitor at T is equal to 0 second. So as we know that the capacitor is fully charged. Okay. So we can calculate the the charge of the capacitor. Okay, by using equation Q0 equal to C0 V0. Therefore, we can calculate C0 dia dah bagi 1.02 micro. And the battery is given 20 volt. Right, okay. Betul, 20 volt. Betul ni soalan bagi. Okay, so Q0 kita boleh kira lah. Where Q0 is 2.04 times 10 power of negative 5 coulomb. Okay, so this is the answer for C. Okay, and then D. Okay, the value of Q at 60 microsecond. Okay, kan tadi ini adalah maximum charge. Okay, so at T is equal to 60 microsecond. Berapa charge yang tinggal? Okay, so kita tahu this is discharging process. Okay, so kita guna formula discharging lah. Okay, sama je macam kita buat sebelum ni. So kita nak kira Q. Q0 tadi kita dah ada 2.04 exponent negative 5. E, T kita 60 micro. R kita dah kira tadi 56.6. And C is 1.02 microfarad. So micro ni actually we can cancel out. Okay. Okay, RC pun tadi kita dah kira kan. Masukkan terus pun boleh. Okay. Sebab RC yang dekat soalan B ni kita dah kira dah time constant. So RC we can straightly calculate. So 60 micro bahagi dengan RC. RC kita dah kira tadi. 5.8 exponent negative 5. So, kita boleh teruslah dapat jawapan 7.3 exponent negative 6 coulomb. Okay? So, finish example D, example number 5. Okay? So, yeah, see you in the next video. Alright, so let's try another question on subtopic 2.3. Okay, Assalamualaikum. Jumpa lagi. Bye-bye.